Hi, I am Pravaha Neupane, and this is my friend Koteshwar Rao Bomala, and we're uh, going to start our group video presentation. And uh, the topic for the group video presentation is number one topic is mastering the game of Go with deep neural networks and research. And the another topic is mastering the game of Go without human knowledge. And the first topic will be presented by me, mastering the game of Go with deep neural networks and research. So, uh, so in this topic, there is the new concept of the computer Go's strategy, which uses the value networks for evaluating board position and policy networks for selecting moves. And also there is the novel combination of supervised learning and reinforcement learning train such deep neural networks. The neural networks perform go out at the level of nation Monte Carlo tree search systems that simulates millions of random gameplay of self-play without using any look ahead search. A new search algorithm that combines simulation of Monte Carlo with value and policy network. So these are our main topics which we are gonna explain through. And what is MCTS? The Monte Carlo tree search. Monte Carlo tree search, it estimates the value of each state in a search tree with the help of the Monte Carlo rollouts. And the search tree grows bigger and the subsequent values will become more accurate when the simulation are executed. This strategy selects children with higher values, thus improving the select search action over time. Thereby, it converges to the optimal value functions. And the game of Go. I'm going to describe about the game of Go, which is played on the grid of black lines, consisting of the white and the black coins, and it consists of the 19 into 19 image, which with 361 intersection to construct a representation. And there is the use of neural networks to reduce the depth and breadth of the source tree, and the stones which are used, they are played inline intersections, and there are approximately 250 into 150 moves. Supervised and reinforcement learning of policy network. So in this phase, at the first stage of the training pipeline, the prediction of the expert moves in the game of Go is governed by supervised learning. And then the training of policy network is done on a random basis using the rollout policy and the supervised learning. A reinforcement policy network to the supervised learning policy network, thereby increasing the probability of winning the more games. And at the second stage, the reinforcement learning policy gradient is introduced to improve the policy network. The diagram shows the different policy, supervised policy network, value network, and the graph with the training accuracy on KGS database. What is Monte Carlo search? Monte Carlo search, it mainly consists of the four systems, which consist of the selection, expansion, evaluation, and backup, which is as shown in the figure. And then our another topic is searching with policy and value networks. So in this phase, AlphaGo combines the policy and value networks in an MCTS algorithm, and the KGS ranking achieved online is shown by the horizontal lines, which is as shown in the figure. And inclusion of the games against European champion Fan Hui, which used longer time controls, and 95% confidence intervals are displayed. It provides the full details of the asynchronous and distributed MCTS. So the AlphaGo is tested against the world's champion Fan Hui in playing the games, and for thus in the evaluation of the strength of the AlphaGo, the international tournament has been conducted among the variants of AlphaGo and several other Go programs, which includes the very strongest commercial programs like the Crazy Stone and Zen, which are based on the high performance MCTS algorithm. So in this game, AlphaGo win of around 494 out of 495 games against other Go programs, that is of around like 99.8%. And also the distributed version of the AlphaGo is tested with the single machine AlphaGo programs, where it is found that it is more powerful and win every single game against the single machine AlphaGo programs. And after the distributed version of the AlphaGo programs, it is tested against the FanHui, and it won the matches of 5 games to 0. That is almost like 100%. And the figure shows the game between the AlphaGo and the FanHui. So in the first project, we mainly discuss about the development of the Go program, which is based on the deep neural network and the tree search. And thus, we are successful in developing the Go program by defeating the strongest human players. And what it does is that it establishes a novel search technique that integrates the neural networks evaluation with Monte Carlo simulations. And also the distributed version of the AlphaGo shows the proficiency level in Go by combining the tree search with policy and value networks. And in the process, we go through the different methods and evaluations, where game like chess, checkers, Othello, backgammon, and Go are tested. And for this, the optimal value functions are computed by using the minimax search. And the strongest current Go games are based on the MCTS, which shows the high probability of moves. Also, for the evaluation of the relative strength of the computer Go program through the tournament and measuring the Elo rating of each program, we find that the probability of functions computed by the bias Elo program using the standard constant C. And the match against FanHui was played for 5 formal and 5 informal games with 7.5 Komi, which is without the Chinese rules. And this table shows that the match between the AlphaGo and the FanHui in different phases, how the AlphaGo defeated the FanHui, and what are the ranking of the AlphaGo in every position, and what are the win percentage rate. So in the paper, we are able to develop the Go program by using the deep neural network and research. And for this, we use a novel search technique, which combines the neural network evaluation with Monte Carlo rollout. And also it shows the strength and the performance of the AlphaGo. AlphaGo beats the human most powerful person FanHui by the win rate of around like 99.8%. Thus, this is one of the successful achievement in the history of the artificial intelligence. Though this is the one of the challenging task, but it is considered as one of the great achievement in the artificial intelligence field. And our next topic is mastering the game of Go without human knowledge, which will be presented by my friend Koteshwar. I'll hand over to you.
Yes. Yeah. Thank you, Nipan. And the topic is the mastering the game of Go without human knowledge. And start with the introduction. And a long-standing goal of artificial intelligence is an algorithm that learns tabula rasa, like superhuman proficiency in challenging domains. And the AlphaGo was the first program to achieve the superhuman performance in Go, though A policy network that outputs to move probabilities, and a value network that outputs a position evaluation. And the most challenging domains in terms of human, human intellect. And the policy network was trained initially by supervised learning.
Sorry.
The second one, and in this, reinforcement learning in AlphaGo 0. So in this method, the neural network takes as an output, and the neural network combines the roles. And the main idea of the reinforcement AlphaGo 0, and MCTS may be viewed as a self-play algorithm. And in this method, it uses a deep neural network with parameters. And this neural network takes as an input the raw board representations of the position and its history. And the neural network in AlphaGo 0 is trained from games of self-play by a novel reinforcement learning. And as it consists of many residual blocks of convolutional layers with batch normalization, and a simple and it will be based on the policy to select each move, and then using the game winner z as a sample of the value. And the main idea of our reinforcement learning algorithm is to use these search operators. The next slide. And and the picture in this shows the self-play reinforcement learning in AlphaGo 0. And the program plays a game like S1, S2, S3, like the ST against itself. And each position ST and MCTS alpha pi is executed, and the new parameters are used in the next iteration of self-play. And in this, the MCTS may be viewed as a self-play algorithm that gives neural network parameters, that is pi and position. Neural network is trained by a self-play reinforcement learning, that algorithm which uses MCTS to play each move. And in the first, the neural network is initialized to random weights, that is pi naught. And at each subsequent iteration, the games of self-play are generated, and a move is played by sampling the search probabilities. And again, yes. And second thing, in this, the figure shows the empirical analysis of the AlphaGo 0 training, and in which the MCTS is in AlphaGo 0. So in this picture, we can see, yes, in this picture, we can see that each simulation traverses the tree by selecting the edge with maximum action value q, plus an upper confidence bound u that depends on a stored prior probability p, and which is count n for that edge, which is increment once traversed. B, the leaf node is expanded, and the associated node position S is evaluated by the neural network. And each simulation traverses the tree by selecting the edge, and action value Q is updated to track the mean of all evaluations. And to assess the merits of self-reinforcement learning compared to learning from human data with that trained a second neural network using the same architecture. The next slide. And in this picture, it shows the empirical evaluation of AlphaGo 0. And in this, the performance of self-play reinforcement learning, and the plot shows the performance of each MCTS player from each iteration of reinforcement learning in AlphaGo 0. And the yellow ratings were computed from evaluation games between different players using 0.4s of thinking time per move. And for this data, using the KGS data set, and also the B, prediction accuracy on human professional moves. And the plot shows the accuracy of the neural network at each iteration of self-play in predicting human professional moves from the dataset. And, and in this picture shows the comparison of neural network architectures in AlphaGo 0 and AlphaGo Lee. And the comparison of neural network architectures and either using either separate or combined policy and value networks, and using either convolutional or residual networks. The combinations dual ES and correspond to the neural network architectures used in AlphaGo 0 and AlphaGo Lee respectively. And each network was trained on a fixing knowledge. And in this, the picture shows, and this picture shows the knowledge learned by AlphaGo 0. So in this, the Go knowledge learned, in this picture shows the Go knowledge learned by AlphaGo 0, and the timestamp of that iteration is indicated, and the residual network. And the next one, it shows the performance of AlphaGo 0, and the subsequent, and this applied our reinforcement learning pipeline to a second instance of AlphaGo 0 using a larger neural network. And AlphaGo 0 rapidly progress, and it can be evaluated the fully trained AlphaGo 0 using an internal tournament against AlphaGo and AlphaGo Lee and several previous Go programs, and that also played games against the strongest existing program. And AlphaGo Master, a program based on the algorithm and the architecture presented in this, but using human data and architecture presented in this, and which can be defeated the strongest human professional players in online games. And the next slide, the next slide. So, and the next one, the methods which are used in reinforcement learning, and the classification based reinforcement learning improves the policy. And the the AlphaGo 0 self-play algorithm can be similar, and that can be many rollouts are executed for each action. The action with the maximum mean value provides a positive training, while all other actions provide mean value provides a positive training, and that provides a negative training examples. And a policy is then trained to classify actions as positive, negative, and used in subsequent rollouts. And this may be viewed as a precursor to the policy component of AlphaGo Zero's training algorithm. And a more recent instantiation, the classification-based modified policy iteration, also performs policy evaluation by regressing the value functions towards rollout values. And in this, the self-play reinforcement learning in games. The self-play reinforcement learning has previously been applied. In this, the MCTS may also be viewed as a form of self-play reinforcement learning, and a self-play reinforcement learning yeah, approaches is most directly applicable to zero-sum games of perfect information. And the formalism of alternating Markov games described in this, noting that algorithms based on value of policy iteration and extends naturally to this setting. And the MCTS may also be viewed as a form of self-play reinforcement learning. And the nodes of the search tree contain the value function for the positions, and the nodes of the search tree values are updated to predict the winner of some simulated games of self-play, and it has proven the highly effective in video games. And the next one is domain knowledge, and in this, the primary contribution is to demonstrate, and the AlphaGo Zero is provided with the perfect knowledge of the game rules. And the primary contribution is to demonstrate the superhuman performance can be achieved without human domain knowledge. And to clarify this contribution, they enumerate the domain knowledge that AlphaGo Zero uses explicitly or implicitly, either in its training procedure or its MCTS. So these are the different alternative Markov games. And the AlphaGo Zero uses prompt Taylor scoring during MCTS simulations and self-play training. This is because human scores are not well defined if the game terminates before territorial boundaries are resolved. And the AlphaGo Zero does not use any form of domain knowledge. And the algorithm was started with random initial parameters. And after that, the neural network architecture shows that the batch normalization and escape connection that ends the input to the block, and a rectifier non-linearity, a fully connected linear layer to scalar. So the best current player as selected by the evaluator is to generate data. In each iteration, it plays around 24,000 games of self-play. And for the remainder of the game, an infinitesimal temperature is used, which is pi not to zero. And additional exploration is achieved by adding to the prior probabilities to the root in the root node. And the next slide. And this picture shows the input futures which are processed by a residual tower that consists of convolutional block followed by the convolutional block applies to this like batch normalization, and you see a rectifier non-linearity and a convolutional of 256 filters of kernel size 3 into 3 with stride 1, and each residual block applies to the modules sequentially to its input, which is a convolution of 256 liters of filters of kernel size that is 3 into 3 with stride 1, and a skip connection that adds the output to the block, and a rectifier non-linearity, and a batch normalization, and the value head applies to the modules that kernel size which is used to the batch normalization. And, and and coming to the conclusion part, a pure reinforcement learning approach and its results comprehensively demonstrate that a pure reinforcement learning approach is fully feasible, even in the most challenging of learning approach is the domains, and also it is possible to train to superhuman level without human examples or guidance, given no knowledge of the domain beyond basic rules. And furthermore, a pure reinforcement learning approach requires just a few more hours to train and achieves much better asymptomatic performance compared to training on human expert data. And using this approach, AlphaGo Zero defeated the strongest previous versions of AlphaGo, which were trained from human data using handcrafted features by a large margin. And also, the humankind has accumulated Go knowledge from millions of games played over thousands of years and collectively distilled into patterns, proverbs, and books. And moreover, in the space of a few days, starting like AlphaGo Zero was able to rediscover much of this Go knowledge, as well as novel strategies that provide new insights into the oldest of games. And that is the part of the mastering the game of Go without human knowledge. Thank you, Nupen.